semester 2, you are over 25% of the way done with middle school. Well, 7th and 8th grade. I got to get used to 6th grade and change my percentages, I guess. You're like halfway done, I guess, because all of 6th and then half of 7, and then the other half of 7 and all of 8. But all that to say, we need to be developing good habits, right? How do we hold ourselves accountable to get our work done? When do we turn off the Netflix and actually do our homework? Because multitasking does not really help us.
Do I have to specify trapezoid or just quadrilateral?
Quadrilateral is probably it's still true, but trapezoid's better, right? So I mean, quadrilateral is not wrong; it is correct. Trapezoid is better. The parallel box plots here. Obviously, the post-emergent has a much bigger spread than the pre-emergent. So they say there's no real outliers because the data is pretty close together. Any questions on these top problems? And then our graph here should be a straight line going through / coming from, however you want to say that, the origin. So that means it is proportional, right? Part C asking, is it proportional? Yep, of course, it's a straight line coming from the origin. And then 79 was one of those where you had to take words and make them into algebraic expressions, right? Any questions? Otherwise, we got a lot of constructing shapes to kind of grapple with today. If you know your Chromebook's dead, you should probably pull it out and get it on a charger. If we have time, we're probably going to end up using Chromebooks at the end of the lesson. I have a hunch what I'm going to ask you guys to do might end up getting frustrating. Just because if I was asked to do it, I'd probably end up frustrated. Just because I'm not a very good drawer. You're probably a better drawer than me, though. But if we end up frustrated by manually trying to draw, we can probably use some technology. All right, no questions? All right, for our friends playing along at home, just in case you missed this, this is what you would need. Especially if we can't not break rulers, maybe we should use technology instead. All right, but we need 834 out. So please get that out. If you don't, I'll give you a minute to transition while I grab my 834. Now, once we start the lesson, I'm then going to pass back some papers, because I got papers for people. But if you are working on 832 right now, put it away. It's practice work you do outside of class. Don't make me call you out by name. That's embarrassing. Quit doing your homework. We're doing a new lesson now. So I want you and your partner to look at question 91 together. And not only answer how many parts do you think a triangle have and talk about what the parts are. And if you don't have 834, grab them back there, guys. But then what else do you maybe know about those parts? Right? So how many parts does a triangle have? And then what have we figured out so far about these triangles? And I think I showed 3D something I forgot to show you guys, so we'll do that today and help us formalize what we know about triangles. But go ahead and talk with each other. Take a couple minutes. Write down on your paper what you figure out. 91, first thing on your paper. Yes. So thank you for that reminder. Hold up. Give me your ears real quick. The chapter 7, Progressing to Mastery. My plan was to get it into math during my planning period. Guess what didn't happen? That. So my plan is, we'll see if it happens, to put those in math tonight. About half of you maybe have turned them in so far. So chapter 7, Progressing to Mastery, the white paper, that's just front and back, no staple. Right? Progressing to Mastery, that needs turned in. Your revisions that we did together in class, that also should get turned in, but honestly, the Progressing to Mastery is even more important, because that's a mastery grade now. The revisions, if you check math, actually I forget if I changed it for you guys yet, the revisions, that's just going to be a practice grade, like a check grade. All right, chat with each other about triangles. Turn to your Progressing to Mastery if you got it. Take a couple minutes. I totally just lost track. Oh, I was going to go cut some triangles. From chapter 7, we went over the revisions together in class. Wait, so last week, Thursday, were you sick at all last week? Thursday, you gave back the masteries and went over it. You did like all the corrections together. Friday, I gave you a progressing mastery and you worked on that in the whole class. You may have already done it. Like, so yeah, if you've already done it and turned it in, no worries. Oh, I owe you a soccer, don't I? I can't ever remember who I owe things to.
You owe me a.
No, I do not. So
You owe me an everything bagel with cheese. I made you a poster. You do.
you were supposed to do corrections together as we did it in class. So if you don't have a piece of graph paper with that with corrections on it, you might need to come talk to me. Is Bryson normally in this class or his paper? Okay, so he's absent today. Okay. Let's use some cards. Man, I keep shutting this just out of habit, and I don't know. Okay, it's just because of habit. Leave this open. Violet, what did you and Adele chat about with the parts of a triangle?
Well, we were talking about how it has the like inner angles and like the outer angles and like vertices and lines.
So I love that you just brought up all of those details, but I will say the outside of shapes we don't normally talk about because that gets like a bit too complicated if we, then we're talking about everything, right? So I love that you said that, but if I throw a triangle up here, you said we have the inside angles. So how many of them? 3 angles. And guys, this is where, sorry about my G, but the symbol for an angle, not the less than symbol, because the less than symbol is like angled on the top and bottom. This is the symbol for an angle. And if you're going to talk about the measure of an angle, you can either do M angle, or you can do the angle symbol with a little arc that talks about the size of the angle. So if you want to be able to like shorthand or abbreviate what you're writing, you don't have to write the word angles. We now have symbols for it. Right? So if you're going to say angle A, we would say angle A if we're talking about how big it is. But you don't have to write the word angle. You just do this. So 3 angles. Wait. Yeah. Okay, ask it.
So you could use all of those interchangeably?
Except this one doesn't really mean the size of it. It's just like if you're naming it. So if I'm just saying, hey, here's angle A. But if I say angle A is 52 degrees, I would probably use the one with the arc to say the size of angle A is 52 degrees.
So what's the
This gets used more often.
what's the M for then?
Measure of. This and this are the same thing. It just depends if you want to say measure of angle or if you want to use the fancy pants symbol. All right, so 3 angles. I don't think that's all that we got. Noah, what else? How many sides do we have? All right, 3 angles, 3 sides. Now, in a right triangle, those sides get some particular names, but in a regular triangle, we really just call them like the sides, the edges, whatever you want to say. So,
Also, we know that all the angles add up to 180.
ooh, all the angles add up to 180. Now, if you're like, wait, like we know that? And don't let somebody just tell you memorize this because I said so. That's lame.
Oh, my other teachers at other schools.
Yeah, one of the homeworks mentions it.
Yeah, well, I know, but like, how do we know that's true? All because you see it doesn't mean it's true.
The homework actually makes you do it on your own.
Okay, can you prove to me why it exists? Like, why it's true, or just you've seen it happen? If you know what I'm about to do, that's awesome.
I don't know. I can't really prove geometry as well as I can prove algebra.
So I just randomly cut 3 triangles out of a piece of paper. Okay, I think we can all agree that these triangles are different. I guess these two look kind of the same, but I could tweak one if I wanted. Here, we'll make it a right triangle that's skinnier. We'll just do that. Will that change? Well, not if I cut at the right line. If I get to the vertex, so obviously 2 different right triangles, right? Because these are not proportionally equal to each other. And then an obtuse triangle, right? Because we have one obtuse angle. Watch this. Green triangle, we'll label the angles ABC. Purple triangle, let's label the angles ABC. And red triangle, let's label the angles ABC. So let's say I've had a rough day, or like maybe you're doing your homework and little brother walks up and he grabs your triangle and all of a sudden you turn around and your triangle has been ripped into 3 pieces. And you're like, bro, what the heck? But then they fall to the ground and just so happen to line up with all the vertices pointing into each other. And while you're busy looking at this, your little brother grabs another one of your triangles, rips up into 3 pieces, and then, because your house must have some sort of magic happening, they line up with your other one and also make a straight line. So now we essentially have made 360 degrees because each of them made, but both of those were right angles. So maybe this one's different. Nah, but you guys are smart. You know this isn't going to be different because, I'm teaching the lesson. And again, any triangle we have, if you rip the angles apart from each other and line them back up, vertices all together, it's going to make 180 degrees. Now we will formalize, because this is just showing, right? This is not proving. We will formalize here later in our learning. What's up, guys? No, well, of course they're going to know this. All right, so I guess continue the angle discussion. Has anyone figured out anything about the sides? So we know the angles sum to 180. Has anyone figured
There are 3 of them.
There are 3 of them. All right, very good.
Exactly.
Anything else? Can I make a triangle out of any 3 lengths?
Yeah.
Ooh, you put a technically on it, which I don't know why you guys say technically so much. So hold on. What sort of triangle would have 2 legs that are equal to each other? What sort of triangle? That is not helpful. Lucy?
It could be an acute or an obtuse.
There's a specific name.
Isaac, don't you say that needs to
2 legs. That's when all 3 legs are equal to each other. Isaac?
He copied me. I said it out loud and then he shot his hand up.
Hey guys.
Copied me.
So
I knew
here,
first.
hey, hold up. Let's make sure we all agree on some angle or some triangle vocab. Scalene. You should write these down. If you choose not to, I will say I told you so. Scalene. 3 different lengths. Now here's where it gets cool and the letters actually indicate something to us. Isosceles. What do you notice about the top and bottom of an eye?
Wow.
They're equal to each other. That is not parallel. Don't let your brain think that. The top and bottom of an eye, sure, but ignore that. Because that won't help us here. Because nothing's parallel in a triangle. So quit saying parallel. Isosceles. Isosceles is 2 equal sides and then 3 equal sides. Lucy already said it. Equilateral, which we notice, depending on how I draw my E, Those have 3.
And it says equal. And they're parallel. It says equal. Mr. Hudson.
Scalene, isosceles, equilateral. Yes.
You spelled it I-S-O-C, but the poster
Oh, crap.
I-S-O-S.
Yeah, there's another S there. Is there a C? There's a C somewhere.
Oh,
Yeah,
after
there's an
the
S
S on
between.
it.
So this, I done goof. Hey, you get a sucker for catching a typo. Isosceles. I forgot the sauce. Don't forget the sauce. Your ribs won't be any good. Sam?
So, Miss Hoffman was telling us a story about you, like, saying moist to get on our nerves.
Does this have anything to do with our lesson? Aside from the fact that Nick intentionally said something to get on my nerves and I ignored it. Okay, moving on.
Equal, you also spelled equal up there as
Oh my gosh! I quit.
Mr. Hudson,
Oh
throwing
my.
a ruler isn't good publicity. It'll scare all the kids away who want to come
I
here.
do that anyways.
Yeah, well, that's
Oh,
because
well,
I
Nathan.
actually didn't know you before I came here, or you might have scared me away.
Yeah, I know, I do that. So, okay, so isosceles triangle. 2 equal sides. You gotta envision with me that this little thing on the bottom isn't there. Oh, I can unscrew that apparently. And that these actually make the vertex. Ignore the extra bits at the top. Colin, did you have something to share?
For equilateral, it's in my brain it's equilateral lines.
Yeah, because lateral like means like lines, right? Like lateral is one like lateral. What's lateral mean in football? What is a lateral pass?
A backwards or right or
Yeah, like sideways, really, right? Like a sideways pass. So lateral,
Not
on a
forward.
lateral.
It's
So-
not forward.
Okay, so I got an isosceles triangle here. Could my third side be really short? Yeah, be like a really tall triangle. Could my third side be? I think these are almost equal. Could my third side be like equal to my first 2 sides? Yeah, I mean, then I'd have an equilateral triangle, right? But could my, wait, if I do this, is this a triangle? That's why I said no. So this is why Zach said technically no, he says, because if I call this 3 feet, 3 feet, 3 feet, those are just 3 and it's not equal, like, it's not equilateral, I don't know, I start to think, depending on the
Still a
lengths I
triangle.
have,
There's 3 sides.
but if it doesn't connect, so what we're saying is don't
Make
imagine
longer
this is,
lines.
but what if this is all I have to work? They're just 3 lines.
Well, then the other triangles is bad. You need a longer line.
That's it. Well, tough. Life doesn't always give you what you need. So,
Steal a longer line from your neighbor.
what I need you to do on your paper, like we did yesterday, create a triangle. These are 3 different triangles, right? Create a triangle. Wait, crap. Now I'm getting confused because people are messing with me. I think we're going to try to draw multiple triangles fitting these criteria. I think this is on your paper, honestly. Yeah, 92. It's on your paper, so you can read your directions.
But I don't want to.
There's also a Desmos version.
There is not.
I mean, there's a CPM
You are correct.
in Desmos.
Mm.
Even at the global pass art contest thing like that.
So, am I asking you to be on your computer right now, Val? Like we did yesterday on your white computer paper. How many different triangles? So, initially, the 2 of you might make 2 different triangles. Right? What we're trying to answer is how many different triangles could we make with these rules? So, for triangle A, how many different triangles could you make that had one length of 4.5? Bless you. And one angle of 135. Do it. Talk with your neighbor. Then when you think you have an answer, move on to B. How many triangles can you make with 2 given angles? 90 degrees and 60 degrees. And then how many triangles could we make with 2 given side lengths? Your 135 should be obtuse, right? Make sure that you used the correct 135. Your 135 should be obtuse. So 4.5 centimeters, right? Not 4.5 inches, 4.5 centimeters. 135 degrees should be a nice big obtuse angle. Anyone notice what 135 actually is if you kind of like break it up? Yeah.
Oh, it's
Lucy?
isn't it like 345?
Yeah, it's like it. Well, you could either say it's 345s or it's a 90 and a 45. So wait, we said the 135 is like a right angle and then half a right angle and half. Oh wait, cough cough. Homework answer. If we said 135 is a right angle and half, okay, just trying to help you out.
Everybody immediately turns to their homework.
Well, it's the same paper. This should be in front of you.
Let's go. Free answers. Wait, what? Cheater. How am I cheating?
Exactly.
Well, excuse moi.
So once you and your partner think you have an answer for how many triangles could be made with a 4.5 and a 135, you can move on to B.
You can't make it infinite. How about only one? So pretty on. You can't keep drawing a line on infinity.
I mean, hypothetically, you
Yes,
could
Mr.
make any
Hudson.
line longer. Way to cut me off before I finish my sentence. Hypothetically, you can make any line longer, but you are correct. Infinity is an idea. Infinity cannot be a length.
Mr. Hudson,
Yes?
have you seen the Netflix show Trip to
Nope,
Infinity?
we're moving on back to our math lesson because we have way too much to do to be off topic. And I doubt that you've answered questions 1, 2, and 3 here. So 4.5, we said if we make something intentionally a certain size, we're going to label that. And then 135, we just said, is like a 90 degree and half another 90 degrees. So if I use my protractor, I'd get something close to this. But whether you put it on the left side of your triangle or the right side of your triangle, if we make it a certain size, let's label it. And, well, I got cards out. Colin, you got an idea? You and Sam figure out how many you think can be made? Adele? Have you and Violet talked about how many could be made? You're still working? Rin, I saw leave school. Soph, what are you thinking?
Well, Annabelle thinks it could go on for infinity because if you kept extending the line, the triangle would just be more skinnier towards the end.
So we know this length is fixed. We know this angle is fixed. But if I do like I did yesterday and in pencil make my hypothetical line, and Soph says, Annabelle thinks this really, well, aside from my page stops, but could I connect my triangle like this, and did I satisfy the conditions? Yes. Could I connect my triangle like this, and did I satisfy the conditions? Yes. Could I? So how many different triangles like this do you think could be made? Hypothetically, infinitely many, but we can't actually make infinity. It's an idea. So the question really is, could you make another one? Yeah. And then could you make another one? That looks different, right? Like, yes, we could keep making other ones. We might need to get bigger and bigger paper, but we could keep making other ones. All right. So, Leah, what about B? Or 2? On your paper, it's 2.
Well, I thought that there could only be 2 because I don't know why I thought that there was.
Okay. So 90 and 60 I'm just gonna pick, I don't know. They didn't give me a length, so I'm just gonna pick a length of like 5. I don't know. Oh wait, so hold on. What'd you just say? But why? Keep saying more. So if I make this 90, and then I really should have been doing this in pencil, and then I make, let's say my base angle 60. Where did I lose my protractors? Oh, I put them all back here. Thank you. Question is, do you guys have these drawn? Because I can't even get them drawn this fast. My zero's on my left side now, right? My zero's on my left side, so I'd be using this 60. If I'm using that endpoint, so that 60, I might be interacting with my other triangle. So if that's 90, and we made this 60, and we said every triangle's angles sum to 180, what is this angle up here? 30 degrees. Is there any other option?
No.
Zach? I just broke my computer. Oh, there we go. So guys, this, regardless of if I flip it over, if I turn it, you might have a triangle that looks different, but literally we all drew the exact same triangle. Except for what Leah already said, except our triangles are different sizes. So this, in part B, guys, what you should write down, with a 90 and a 60, the other angle has to be 30. And what that means is all of the triangles that we would make, if they're actually the same triangle but different sizes, what do we call that? Starts with an S. It's the math word that means the same but different. Well, this is a scaling because it has 3 different lengths, but similar. I think a couple people said it. So you guys, all similar. You got to say it louder. I literally have hearing damage out of my right ear, so honestly, I hear that side of the room better. All right, try this. 2 side lengths, 4.5 and 7. So now we had 2 angles told us everything's going to be similar. What about 2 side lengths? I would start with the bigger one just because it's bigger. It's got more to draw. I would start with the 7.
Would the all similar thing be the same for number 1 too?
Nope. Number 1, they were all different. Infinitely many possibilities. So 7 centimeters. Could my I'm just going to go 4.5 in from my 30. So 30 minus 4.5 is 25 and a half. So all of these are 4.5. Could I make a triangle like here? Did I satisfy the conditions? Yep. You know the questions I'm going to ask. How many colors? I'm running out of colors. So how many triangles could we make when given 2 lengths? Again, it seems like infinitely many. So, infinitely not similar. Because these are very much different triangles. Like, do these look the same? No. Hey, Sam, am I boring you, dude? You look like you're ready to take a nap. We're like writing stuff down and drawing stuff, and you're like halfway to a nap. Come on, man, engage with us. You're hurting my feelings. If you need to take a walk, but you're hurting my feelings. Yeah.
So it seems like. Guys, where else?
Yeah, I hate when that happens. So now if you want to use some technology to play with this, if you get into your Chromebook and you go to 834's lesson, and guys, you can always use this tool and actually, guys, once you get comfortable with the tools, are you kidding, bro? You know I'm in school. So if you hit right here, 894 triangle creation E tool, and there's also just a generic like triangle tool. But so not a Desmos activity like when I'm tracking you and when we're doing step by step by step. This is a free Desmos workspace where you can do whatever you want. So like I'm not tracking your progress, but you can save these things. So as a few of you keep asking me about showing more Desmos art stuff, which we just don't have time. If you want to look at that stuff, look at it on your own time. But in this e-tool, you can see how you can move things around. Depending on what they allow us to do, sometimes you can click on the angle and see how big it is. So we have like 5 minutes left. I just want you to get into the Desmos e-tool and like play with this. I will say though, it's still frustrating. Like, because if I'm trying to make a triangle, so like try triangle, let's all try triangle 1 first. Let's get 1.55 and 4.5. So once you get in there, and I think sometimes I can use this grid line, because I think each of those grids is like a centimeter. So I got my 5. Guys, if you want to drag the background space, just grab the background space. 4.5. Now I got to make 4.5 and 1.5 happen at the same time. Now I got to figure out like where is that spot where I can get 4.5 and 1.5. Crap. Oh, there's 1 point. I wonder if I can lock this. I can lock this length. So here's my angle sizes. If you scroll down here, now we can see what size the angles are. Oh, hey, look, they give us the total. Crap, but nothing about locking my... So I'm not successful right now. Right? I got my 5, I got my 1.5, but I need 4.5. So guys, this is not, like I told you guys, this is not frustrating. It just might be less frustrating, maybe. Maybe? It might be more frustrating. I'm not sure. So I need to keep my 1.5, but rotate this. Oh, I'm almost there. Almost there. I'm so scared. Oh, come on! I don't know about you, but I am frustrated.
Why? You sound frustrated.
Well, I am frustrated. Actually, I'm Mr. Hudson, but... worst dad joke ever. We talked about where crayons go on vacation, right?
Yes.
Oh,
Okay.
yeah.
Do
you know where TV remotes go on vacation now? No. In the cracks of the couch?
I don't know. A remote island?
Yeah.
He
got it!
We might as well, while you're struggling, to try to lock those in. What? Which rock group has 4 guys who can't sing or play instruments? If you say the Beatles, you're going to hurt me deep to my core.
Beatles. No. Get him!
Which rock group has 4 guys who can't sing or play instruments? I think you are trying to think of the Rolling Stones, but no, they're also very good at what they do. Mount Rushmore. Rock group. Right? Not. You got it, Isaac. You finally fought it to get there. All right, so even if you've not gotten to the point of Isaac of actually making it work, Isaac has proven A does work. This first one does work. Try to make the third one. Jump down to 3 because we don't have time.
I got it.
Jump down to the third one, the 1.5, 4.5, and 7. So like,
No, I'm not using a mouse.
so you need to go to the CPM ebook. This is why I said it's not Desmos. This is why, Val, I appreciate you thought you were helping, but you actually did the opposite. It's in the ebook. If you are still looking for what we're doing, it's in the ebook. I feel like that was a lie. Like your computer lied to you. So I don't know. I mean, you guys can work together. We only have like 3 minutes left. You struggling to find where we're at? We're in the ebook. So the CPM ebook, which there's a link in Schoology where you could just type CPM ebook and you'll get there.
I am very scared.
It just took forever for my computer to load.
It's funny. They'll lower the chapter.
1.5, 4.5, and 7.
Hard on the ebook. Very good.
You scroll down. It doesn't really matter, but if you scroll down on the left, it has the angle sizes.
Which question would the link be in?
So right here, 84, or sorry, not 84, 94. It's on your paper, but we decided we're going to go use Desmos to do it. And now we're looking at part 3.
I can't find 834.
CC2. You in CC2? Guys, I'll even...
This isn't working.
Maybe you're not working.
That's what Mr. Estes told me when I told him that wasn't working.
Where is that?
Your face isn't working. I mean, he told me I was broken.
Here, I'll even drop the link. I don't know if it'll work since this link needs logged in. Like, you have to log into the ebook to do this. But I'll drop the link here so you guys can find it more easily next time.
You know how frustrating this is?
Notice that I put up the Chapter 8 help with Mr. Dell because his stuff is awesome.
This stuff is awesome.
My little
All right, so we are out of time now, so we're going to have to come back to this problem tomorrow and figure out what we figured out. We will start Jenga tomorrow if we're able to. Otherwise, we will do it on Friday. So have a wonderful day, guys. You can keep playing with the triangle creation tool if you want to, but you do not need to. This is not homework, but the rest of the packet is homework. So do your homework. 833 gets checked tomorrow. 833 gets checked tomorrow.